Right, this is first one. Okay, so 0-point hit rate, and we can have 40% savings. And let's check further. 40% saving, then only 60% to go through the access link, and let's check further. So originally we have these, the total rate, right? The total rate, we cannot set 100%. We only set 40%. So we have 60% to go through the access link. So right now, the rate go through the access link is this, 9 megabits per second. Well, if we check further about the access link, about access link utilization this time, it's 9/15.4, and so that near 0.6. Right? So originally we have 99%, but right now approximately 60%. Well, again, we have another assumption. So we have a queuing delay. And this is 99%. So we have a few minutes. And this is a millisecond. It's 15%. And right now, how about this? If we have 60% and use 60%, the assumption here, we assume we have 10 milliseconds. All right, so again, we have the assumption. All right, it's assumption. And you can refer to the textbook again. If we have the assumption, 60%, we have a queuing delay around 10 milliseconds. Well, if so, then we can have the calculation. If we have the current assumption, the delay should be 2 seconds plus 10 milliseconds plus millisecond. So approximately we have 2.01 seconds. For 60% and the delay around 2.01. So that's why we have these. And also 40%, it is not necessary to go through these. And not necessary to go through the access link. So we just have a few milliseconds. All right, so if we have all of these, then it says we have the current result by calculating the total delay with 60%, that says 0.6, we have delay around 2.01. And we have 40% delay, just a few milliseconds. And put them together, we have the average delay. All right, average response delay only 1.2. All right, so this is a current calculation. And then you know if we have 40% saving of traffic to go through the access link, then we only have 60% traffic to go through the access link. So of course we can reduce the traffic to the original server. If we have these, and we have the further assumption here, this one, 60% only 10 milliseconds, around 10 milliseconds. And then we have the delay here. And put them together, we can have the calculation of the average delay. Finally, we have 1.2. If we have 1.2, of course, using average value, we can save time. But I don't know, we can save time for all objects. Why? All objects. Before I check the delay for all objects, the reduction of response time for all objects, I need to make sure up to now about the current distribution. Is it okay for you? If it is okay, then let me use this one to illustrate why we can save time for all objects. So first of all, let me use this way. For the 40%, time saved. Why? Only a few milliseconds, right? So this case, I think, okay. And about this one, 60%, we have a delay 2.01 seconds. And this one compared to a case. Which case? The case without cache. And the case without altering all the capacity of a link. If we refer to that case, and then what is the delay for the response time? This one. Right? So I use the current page. About the 60%, we have 2.01 seconds for the objects here, right? And for the object here, of course, smaller than a few minutes. So that says 40%, a few milliseconds. So of course, lower than the current minutes. And also for 60%, we can shorten the time to 2.01 seconds. And of course, the current time lower than a few minutes for the original case. If I use the two cases to let you know, all objects can reduce the response time. Up to now, acceptable for you? If yes, raise your hands. Up to now, I let you know by using the two cases. Case 1, 40% without going to the original server. And case 2, only 60% going to the original server. And so that we can save time to 2.01 seconds. Of course, the current time smaller than a few minutes. About the current plan, we can save time for all objects. If you can accept this, raise your hands and let me know about this. Is it okay? Okay for you and okay for the other students? In fact, I use the original example. The original example without caching. And of course, about the time we have an assumption here. Finally, we should have a few minutes for all objects, right? And jump to the case with the caching. 40% with the hit rate, 40%, and then without going to the accessing to the original server, and then just have a few milliseconds. A few milliseconds, of course, lower than a few minutes, right? So for that case, of course, we can save response time. But for 60%, 60% here, we have the assumption for sure. This one, we have the assumption 10 milliseconds for 60%. And if we have the assumption, then the calculation allows you to have this 2.01 second response time. Well, so of course, so the current time, of course, shorter than a few minutes. Why? Already we have a 99% to go through the SSE to our original server, and this time only 60%. And so that we can shorten the time. Let me have an example. Think about this. If you guys want to go to the restaurant, and right now I think I assume it's a rush hour. Rush hour, you have a 99% load, and you can feel how long to wait. You are told you need to wait for a few minutes. But this time, maybe for some reason, even it's rush hour, however, the traffic can be reduced from 99% to only 60%. And 60%, we have the different congestion level. Because of a different congestion level, so the time can be cut from a few minutes to, for example, right now the assumption says to 10 milliseconds. And finally, the resultant response time, of course, should be shortened. So that's why the case here allows you to have the reduced response time for the 60% traffic. All right, so for this reason, of course, we can set time for the case here. Even you cannot find object in the cache. You need to go to the original server and request the object. Even for the case here, that's okay. We still can set time. All right, so up to now, I emphasize the time for all objects can be reduced. Up now, is it clear? All right, so finally, if I ask you the question, if we can have the cache, and the cache can set time for all objects compared to the case without any installation of a cache, the answer is yes or no. The answer is yes. So if I ask you to answer a question like this, the answer is yes for all objects, not for some object. If you think for some object, you just consider 40%. Can set time from a few minutes to a few milliseconds. But you also need to consider the other case. If you can have the hit rate, for example, 40, then you can set time. For example, right now, set time from a few minutes to 2 seconds. And that's it. So this is the discussion about caching. Well, about that one, using cache, of course, you need to have the assumption non-zero hit rate, and then we can set time for all objects. If you don't have the non-zero hit rate, for example, you always need to involve the original server to get the object. So can you set time? No, you cannot set time. For that case, you cannot set time. But if we have the non-zero hit rate, then we can set time. All right, so I use 3 examples. Example 1 and example 3 to let you know if we have caching, then we can set time for all objects. Okay, so that one I think I explained 2 times. Finally, you should understand if we don't have a 0 hit rate, then we can set time for all objects. All right, that's it. All right, so finally, if we have a cache and checking the edge delay, edge response delay, we have a 1.2. This one shorter than this case as well. The second case, even approximately 2 seconds. But if we can have the cache, we can cut time from 2 seconds to 1.2 seconds simply. All right, so if we have a cache, then cache is a cheap solution, and cache is an effective solution. So that's why we need to use cache. All right, so this is a reason to let you know why we want to use cache. And you can get back to the original discussion about why web caching. We can save response time. We can reduce the traffic. Yeah, it's true. True for the two claims. Saving time and also try to reduce the traffic go through the access link. All right, that is discussion about web caching. Up to now, is it okay? Well, I assume everything's okay, and let me continue. Well, if we continue and then talking about HTTP, we can have the next one, conditional get. Conditional get says if we don't have the updated version, then it is not necessary to get it. If yes, we have the updated version, then we need to get it. Look at these. We use if modified since a date. Use this one. If anything change, then send me the object, or otherwise I keep it. So it is not necessary to send the object to me. So no, so not modified. How do you know you have it and not modified? So nothing need to be updated. So everything's okay. However, next time, if we have the same one, by checking if modified since a date, and this time, yes, modified. So we already have the modified object, and already have 200 OK to already have the data. If we have these, we can save time as well, and we can avoid sending the object to you. Well, next we will continue to share email, but before I close the discussion, I should let you know today, I let you know some idea about web caching specifically. And web caching, we have the important idea about the concept, saving response time for all objects. And these, I let you know, yes, by using two examples, example 1 and example 3. And if you still have the question, you check it later. And if you still have the question next week, you can let me know. Or maybe you can send me email to let me know your question. All right, about this, any questions? If no, that's it. And see you next week. But before you go, you still keep your Teams on, and so that I can allow you to join some group, because I do not finish the manual setting for the group. Okay, so just go and let me have the setting. Even I cannot finish, next week we can continue. Okay, that's it. See you. Bye-bye.